Okay, and that's what I'm getting on screen of my calculator. I'm getting numbers 1.43739896. You had to write all of them. If you were getting a fraction, remember to press the button S to D. That would simply convert your fraction into decimal. Alright, and now in the question B, you've been asked, write your answer to part A correct to 2 decimal places. So in this decimal, we need to find the last digit that will stay, 4, 3, and the last digit that will stay is 3. So we're cutting out here, and now we think about the last digit 3. Since the last digit that we cut is 7, which is more than 5, so our 3 will have to be rounded up, and the answer would be 1.44. Okay, so now that's it basically about this question. Send me an email if you feel you have more questions about question 4, and if you lost mark but it hasn't been explained why. But as far as I can see, that's everything what you need for this question, right? So let's move on now. In trial improvement, mostly was done really well. The only problem was, again, reading the question, that you see in this sentence in particular, give your answer correct to 1 decimal place. Many of you were able to calculate in correctly, but only to 2 decimal places. Here I don't want to calculate every single number, but I'm going to show you just details and frame of how to approach these questions. So as you see, they're saying that this equation has a solution somewhere in between 3 and 4. Use a trial improvement method to find the solution. Never stop reading. Some of you were so quick to start doing a table or writing your solution straight away, not finishing reading the question. Give your answer correct to 1 decimal place, and you must show all your workings. Alright, because actually this was question 4, as far as I remember, 4 marks. And so you had to be really careful with what you're writing there, okay? So let's start. To present our working in a systematical way, we need to draw a table. So we'll draw a table for values x. Then we will calculate the value of x cubed plus 3x. Okay, and then we will compare our value with 41, and we will say whether it is too big or too small. So we'll write a comment here. Okay, so they said that solution should be somewhere between 3 and 4, but we don't know how far. Alright, so I will calculate the value of the expression that I have on the left side for x equals 3, and you need literally to write down everything what you were doing. You substitute x with 3, so you have 3 cubed plus 3 times 3, which is 27, plus 9, so it is 36, and it is of course too small. Then you calculate the value of that expression for 4 cubed plus 3 times 4, 64 plus 12, 64 plus 12 is 76, is too big, comparing with 41, right? Too big. And the procedure is the following. Now we'll divide this interval into half, and we pick up the next number is 3.5. 3.5 cubed plus 3 times 3.5. In fact, you have to calculate this on your calculator using the correct button. 3.5 x cubed plus 3 times 3.5, and that's what I getting on my calculator. I'm getting 53.375, right? Comparing with 41, it is too big. So the last time, as you remember, our solution was between somewhere 3 and 4. When we picked up 3.5, we have found that for 3 it was too small, for 4 it was too big. That's why we picked up in the middle. But for the number, for x equals 3.5, my answer was too big. So my solution somewhere is in between 3 and 3.5. Alright, because it was too small for 3 comparing with 41, less than 41, or you can even write less than 41, more than 41, more than 41 again. Alright, so to get closer to 41, we have to find now a number in between 3 and 3.5, so you will pick up 3.25, and again you will be evaluating 3.25, and you will come perhaps whatever number is here, it will be small, or sorry, too big, but you need to write it exactly as it is. Don't round it. Write if as many digits as you can, but perhaps like 4 or 5. All right, and that number will be too big. And now what you do, you split in this interval between 3 and 3.25 again into half, and now, for example, you come to 1.7, or and then you start looking at numbers that would be smaller perhaps than 3.17 and 3.16, and you need to be careful when you come to the last number and before you making the last decision, all right, whether it is 3.15 or 3.17. Some of you were really rushing through this example, and although you have tried 3.16 and you figured out that was too big, you still wrote that the answer would be 3.2, but you didn't know actually would it be a 3.14 would be good, but then 3.14 would be rounded to 3.1, and 3.15 would be rounded to 3.2. And since they asked you to give your answer correct to one decimal place, you actually had to look at 3.14 as well as to 3.15 to decide whether your solution is better as 3.1 or 3.2. So please do these calculations accurately yourself and make sure you get in the right answer, which was 3.1 to 1 dp. All right, so looking back at this question, make sure that you write your calculations in a systematical way, organized in a table. Secondly, that you follow in your choice of numbers, you follow some idea that you simply like splitting the interval into half, and you see how to split which part, the first or the second part, to split in half for the next stage, right? And make sure you understand what was accuracy required, and make your judgment accordingly. All right, that's everything for this question. Let's move on to the next one. Okay, here's a question with a right angle triangle, and we need to look at what was given and what was asked. So we've been given a right angle triangle, we've been given one side PR 8 centimeters and another side PQ, and we've been asked to calculate the length of the third side, say X. Look, if in a right angle triangle two sides are given and you've been asked about the third side, the only relationship that would connect three sides in a right angle triangle is going to be Pythagoras theorem. No trigonometry, as some of you were asking, because trigonometry connects sides and angles. There is no information here at all or a question about angles, so we are using obviously Pythagoras. Alright, so to use Pythagoras correctly, we need to find the hypotenuse first. Hypotenuse is the side which is opposite to the right angle and is the longest side in a triangle, so that is the side PQ in this case. So therefore, let's write our Pythagoras with the numbers given. So 16 squared, which is the square of the longest side, is going to be equal to the sum of squares of two shorter sides, 8 squared plus x squared. 16 squared is 256, 8 squared is 64, plus x squared. So we subtract 64, 256 minus 64, I'm getting answer 192. But let's write x on the left side now, x squared on the left side, so I'm getting 192. And I would recommend you to write all equal sign in one line, so it would be really nice ordered way of writing your solution. But I'm going to write now here on the right side. I'm going to square root both sides, 192 square rooted, and the answer is going to be square root of 192 is 13.8564 and so on. And only now let's round to the required accuracy. Usually you will be told how to round. So they want you to round to 2 decimal places. So let's count 2 decimal places. 1, 2. So we cut between 5 and 6. So since the first digit that goes away is 6, which is bigger than 5, so our last digit 5 will be rounded up. So we have x equals 13.86 centimeters to 2 decimal places. Okay, here's the question 5 for you. 6.